Welcome to Factory Forward, the podcast dedicated to advancing manufacturing and propelling factories into the future. Today, we are thrilled to have Prasad Velaga. In this episode, Prasad discusses the challenges of relying on manual interventions in production scheduling, the limitations of Kanban and pull systems in high-variety environments, and the shortcomings of traditional project management methodologies. Now meet your host, Shanzia.
Hi, everyone. We are honored to have Dr. Prasad Velaga with us today. Prasad has been the president of Optisol for the last 20 years, where he develops software for production scheduling. Earlier, he worked as a research scientist on several research projects by the DoD and NASA, and as a professor at the Indian Statistical Institute, Washington State University, and Texas A&M University as well. We are really glad to have Prasad with us, and he's been a thought leader on LinkedIn on all things lean, and especially on the production scheduling side of things. So great to have you here with us, Prasad.
Thanks.
Prasad, please.
Yeah, thanks for inviting me to this podcast.
Prasad, I'm going to jump right into a bunch of questions because I can't wait to get started. You have some you share some amazing content, and I've a bunch of questions around that. Yeah. Can we start by discussing the risks of relying on manual interventions like drag and drop in scheduling tools? You're one of the world's leaders when it comes to production scheduling, so would love to understand a little bit about that.
There are so many software tools for production scheduling, and they are based on different scheduling models and algorithms, but many of them do not have a strong scheduling model. To compensate that, they provide good user interfaces. One of them is a drag and drop. I see value in drag and drop. It is used for three different purposes, as I see. One is to change the starting time of a job, or starting time of an operation of a job, or changing a machine for a job, moving a job from one machine to another machine. How it happened is that this drag and drop, when people develop routings, normally they assign a machine to an operation. Although there may be some other machines which can also be used, but in the routing, they just assign one machine. And the schedule is generated based on the routing information. And in the process, these machines get overloaded. And then the user, normally shop floor supervisors, they want to drag jobs, they want to shuffle jobs across machines, and they find it drag and drop convenient. Right. It happens because enough information is not fed to the tool, that there are alternative machines for an operation. If machine A is not ready, not available, then B can be assigned. That information is not fed to the tool, or tool may not take that. Because of that, people depend on drag and drop. And normally the shop supervisors, they do the same thing on the shop floor without a tool. When a job comes, they see which machine is available, they send the job to that one. So they want to do that on the screen, computer screen. But my point is, if the scheduling algorithms are strong, scheduling model is strong, if it gets right information, there is no need for this drag and drop.
Got it. Yeah, that's very insightful. So that's a situation where having a beautiful UX is actually detrimental to the function, to the actual core functionality of the software.
It is mainly to cover up the weakness of scheduling logic.
Got it. Oh, wow, that's really insightful. Prasad, related but also different question. Why do Kanban and pull systems fail in high variety, order-driven production environments?
These order-driven heavy-ready production systems are quite complex. The demand is unpredictable, and they manage a variety of products. And the demand for any product is unpredictable, uneven, and the different products simultaneously flow through different routings, competing for shared resources to meet due dates, and the product mix keep varying rapidly, and it is not a production line. So because of that, the control and management of such production systems is quite difficult. And most of these systems are made to order. They make a product only after receiving an order, because they can make a huge variety of products. They can't keep final goods inventory because of the reason they make against orders. So if you want to apply Kanban, normally they say the pull starts from customer, right? But how do you start the pull here? Because customer gives an order, he gives a due date. So I don't know how to start pull when there's no final goods inventory.
Right.
And one more thing, this Kanban is mainly to control WIP, work in process, at every workstation. So when you do that, the total work in process in the system is also under control. That's good. In that way, it's good. And so if you quote, Little's law, because you are controlling the WIP, you are controlling the average lead time of products. But the customers of job shops, they are not interested in minimizing the average lead time.
Right.
So they want minimization of a lead time for every customer, for every product, right? And they want, on-time delivery for every product. This Kanban pull, they cannot guarantee on-time delivery for every product individually. And these people who promote Kanban, mostly they are used to a production line.
Right.
So it's difficult for them to imagine how different products flow through the system through different routings. That's what I think every day. But that they work because they are exposed to so much to Toyota assembly lines. It's difficult for them to imagine the dynamics of this kind of systems. So therefore, they say that if you implement Kanban, the WIP is controlled and it solves many problems, but not on-time delivery, not individual lead times.
Right. Oh, wow. So do you think, have you seen any version of Kanban and Poll that is relevant for job shops or high mix kind of situations? Or
Yeah,
they're just doomed to failure in these situations?
it is possible sometimes, from a certain stage onwards, you do additional processes to make products, but up to a certain stage, there may be common operations, So then, if you see common operations for many products, then you can apply, Kanban at the end of that segment. That's where I can see some value of
Right.
Kanban.
That makes sense. That's good. So, how should project management methodologies evolve to address modern challenges, particularly with resource constraints? That's something that you talk about a lot. That's resource constraints are built into your software. But how about these modern, project management methodologies and addressing modern challenges under those constraints?
Yeah, the critical path method was developed by Kelly and Walker in late 1950s. At that time, it was pretty sensational, and from early 1960s onwards, people started using, this critical path method. They found it pretty sophisticated at that time, and for generations, they have been following that. But in my opinion, with my experience in scheduling complex production systems, critical path method is a weak scheduling method because because it addresses only the precedence relations, nothing more. It
Right.
does not take into account the material availability, resource availability, spatial constraints, and many types of constraints. The batching and all. It considers only the precedence relations, and then to overcome the problem, because of the constraints, somehow they try to work around that, and these project schedulers they make a mess because CPM is unable to handle constraints other than precedence relations. So they create artificial precedence constraints
Right.
to manage those constraints. And they violate those constraints during project execution. So then that is also a mess in my opinion. All this arises because of the fundamental weakness of critical path method.
Mm.
And then you see, some people started in 1960s and they became gurus for the next generation. Those became gurus for next generation. And they said this is the way to go for project scheduling. They have
Right.
no concept of scheduling any activity subject to precedence relations and also resource availability. Same time. So what they do, they take the critical path method schedule
Mm.
and then they tweak it to remove a resource overloading. And it's like correction process.
Mm.
But in production scheduling, we don't do such correction process. We schedule every task subject to all constraints.
Right.
So therefore, I want to bring the advanced production scheduling methodology available in manufacturing to project plan scheduling. But here I face a lot of resistance. Most people they don't bother. They is a total alien for them. The scheduling other than CPM. People when they enter project management, their knowledge of scheduling is very poor, I guess, and they're exposed to CPM
Right.
and they know how to work with CPM somehow. That's it. No further development. They don't demand any
Mm.
improvement in scheduling methodology.
Mm.
I think this is going on for generations since the 1960s.
Wow.
But did I answer your question? Or
You
just want
did. You
to?
did. I think what do you think can be done to improve the state of affairs? Is it more technology problem that it's hard to build and replicate some of this technology? Is it more of an awareness problem where people just don't know and the gurus are just preaching something else? The
Yeah. So
simpler critical
yeah,
path that
two things. One is they should have desire to have a scheduling method which is more effective than critical path method. They should have desire.
Mm.
But I don't see that desire in project management world right now.
Mm.
Second, if they have it, then they can look at other fields like manufacturing.
Mm.
Okay, you see, there is some common area between project management and production management. You would see that in large fabrication shops. For example, shipbuilding, right? Shipbuilding, would you consider as a project or would you consider production, right? Manufacturing a large equipment
Right.
that can be treated as a project or production, right?
Yeah.
So I work with that kind of systems. So whatever is working for that kind of manufacturing systems, can be adopted to improve project scheduling.
Got it. Makes sense. Prasad, let's change gears for a bit. What are the limitations of operations research? And maybe you've partly answered this, but what are the fundamental limitations of operations research in current project management, and what innovations are still needed?
The critical path method,
Yeah.
I would consider it as operations research method because I see it as a direct application of Richard Bellman's principle of optimality in dynamic programming. You know, if you apply dynamic programming to project one because it has a network, the precedence, right? Precedence network. And then if you apply dynamic programming at every node, then you get the critical path schedule. So therefore, I consider critical path method as as an OR technique. But after that, there is no improvement at all. And one more thing, in operations research, people are mostly focusing on mathematical optimization.
Right.
But this is a discrete optimization. Here in the project management, is a discrete optimization is extremely combinatorial.
Right.
This scheduling subject to precedence relations and resource requirements and material requirements and other constraints is highly complex.
Right.
It is the extreme case of NP hard, I would say.
Right.
And so many people are not enthusiastic to work on this kind of nasty problems. Mathematical optimization has grown very nicely in a systematic way. Beautiful models, nice algorithms, and all. But
You can't have machine learning without it. Actually, you take a lot of hard constraints, you relax them so that you can pass gradients through them and so on and so forth. But yeah,
but this is extremely combinatorial.
yeah.
I would say in optimization, scheduling problems are the nastiest ones.
Mm.
The resource constrained project scheduling is one of the nastiest optimization problem. This is one of the reasons it did not attract a good operations researchers. But some work has been done by some people, but it didn't have much effect in practice. So therefore, there is still a lot of scope, for war people to improve scheduling methodology. Okay, I did PhD in scheduling a long time back. I worked as a war faculty for more than 10 years.
Yeah.
And then I jumped into applied field. I consider myself applied operations researcher. Using my knowledge, I developed production scheduling software over 20 years ago, right? And I use heuristics. Of course, those are proprietary, but I still see there's a lot of scope for improving. I did something that is useful, but I don't say it's the best one.
Right.
But I say that there's a lot of scope for researchers to get better tools.
So do you mean do you mean in at least in the research literature, are all the right tools available in the research literature, at least people who are doing their PhDs in numerical optimization and those kinds of fields, are the right tools at least available in the form of publications, and the problem is really in commercializing those? Or are you saying that even in research literature, a lot of solutions that just don't exist?
To the best of my knowledge, I never found literature useful for the solutions I developed. However, I developed a thinking process, while doing a PhD and later as a faculty, writing papers. But I developed a thinking process, right? That helped me to create, practically meaningful scheduling algorithms. But directly, I never got any help from literature.
Oh, really? Oh.
Yeah. But maybe available, but I have not seen.
That's a very strong statement coming from somebody who's been a professor and who's a researcher himself. That's a
It did not have any impact on the solutions I developed for practice.
Oh,
wow. And yeah, one thing is in literature they develop these methods putting convenient assumptions.
right.
Convenient assumptions. They don't bother about the real applications. They want to bother about to bring a nice article, a paper.
Right.
It should not be simple. At the same time, it should not be too complicated. They keep adding some assumptions, until they find the problem is pretty good, interesting, and they develop algorithm. But that algorithm is useless in practice because they put assumptions, you know, to dilute.
Right.
Right? That's the reason, the literature is mostly not useful,
Right.
for
Makes
practical
sense.
scheduling problems.
Makes sense. Just
In
geeking
industry,
out, just geeking out a bit because I come from machine learning and their GPUs, so hardware, modern computational hardware, essentially anybody can have a supercomputer on their laptop these days, which is only obviously relevant to certain kinds of computational workloads. These
yeah,
GPUs, single instruction, multiple data kind of processors. Have
yeah.
you considering that a lot of these are combinatorial kind of problems, have you looked into applying GPU
That's quite
compute?
challenging, but the right now I'm an old timer. I'm not looking into those, but I sincerely appreciate the direction. But
Got
I'm not much active or even familiar
in
with
building
that.
new algorithm. Got it. Makes sense. Fair
Yeah.
enough. Can you share some? This is something that you've talked about as well in your content. Can you share some examples where the theory of constraints has been impractical? What alternatives would you recommend? Because there are a lot of followers of theory of constraints, right? But you seem to disagree and you think right. So would love to hear what your complaints about it are.
Yeah, before developing a theory of constraints, Dr. Goldratt developed a production scheduling software like me. It was called OPT, Opt, and I think it was successful partially. I think it is based on analysis of bottlenecks and constraints. And my guess is he wants to promote his scheduling software. And then he wrote the book, The Goal.
Yeah.
Some context, he said he wrote the book Goal to promote his software.
Oh,
He explained his concept of constraints in that book so eloquently, very impressively. Hmm?
yeah.
But it is based on five fundamental steps, right?
Lots of people
Uh,
swear by that book. It's like a Bible.
yeah. And I totally agree with those fundamental steps, five fundamental steps in a theory of constraints. They are very logical and they make a lot of sense to me, no doubt. But if you take it to practice, if you take it to the shop floor,
Hmm.
an ordinary man on the shop floor cannot really make use of them. Not easy. It's very difficult. So therefore, for me, it's a beautiful theory.
Right.
So this is the reason for the last 40 years the TOC is not widespread,
Yeah.
across job shops because finding a constraint, a consistent, predominant constraint,
Hmm.
and ensuring subordination and doing this buffer management, I tell you, is really complex for a common man on shop floor. But if it is done, then it will be very simple. It will be very effective.
Hmm.
So TOC was supposed to be, simple, efficient, and cost effective. So therefore, all the small, complex job shops, they should have been using now, extensively. It
Hmm.
did not happen at all. The reason is the devil lies in details.
Hmm.
So when somebody reaches the goal, is wonderful, so exciting, so exciting. But when people get down to the floor, then they see the devil. So this is the reason
Yeah.
it did not succeed on
Yeah.
shop floor.
Got it. Makes sense. Uh, Prasad, can you obviously you've had a lot of actual shop floor level experience applying, these finite capacity scheduling, OR, other kinds of algorithms to the shop floor. Can you share some case study or some stories of how they successfully or significantly improved manufacturing processes? Do you have any ROI numbers or any such cases off the top of your head that you could say that this is something that should be really impressive?
Well, see, I never made any case study because Our clients, they purchase the software, and many of them have been using for many years, even
Yeah.
from 2006 onwards.
Mm.
Some have been continuously using
Wow.
regularly, and they're happy with that. The fact that they have been using for many years without replacement, that says they are getting some value. You know, they bought it for scheduling purpose, but what benefit they got, I never asked them directly,
Right.
in terms of, but they all tell me one thing, in common. That is, they have good faith in projected, job completion times,
Mm.
so that they're very confident, when they can deliver products to customers. All told me uniformly.
Mm.
But if you really want case studies, I think that the pre-actor, now it's part of Siemens.
Right.
They may have good case studies, on finite capacity scheduling and
Mm.
advanced production scheduling.
Right. So Prasad, I mean, from one entrepreneur to another, how do you how did you figure out the pricing in that matter for your two product if you don't have a quantitative benchmark for the ROI? Because typically what as an entrepreneur, what I hear is, try to estimate what the ROI of your customer is, and then if you ask for 10% roughly of that ROI, that's the right kind of price point for your software. How do you know that you're not just charging way too low for your software?
I'm a bad businessman,
Right. Okay.
right? Having come from academics, I don't know how to run business, frankly speaking. So therefore, I do a bad job pricing this software. You know,
Right.
But I see from my point of view, the cost aspects, how much cost I'm incurring, you know, based on that, is it okay or not?
Mm.
I see from my side, I'm not seeing from the other side.
Right.
It's not correct. What I'm doing is not correct from business point of view. But I'm seeing mainly for my cost and then what margin I get.
Right.
And one more thing, people don't have a uniform impression of this is scheduling software. They don't know how much they can pay.
Mm.
If you take two similar companies, one company may look for a good scheduling tool for $300.
Right.
Another one will look for a similar one for $20,000. So the concept of price in industries about production scheduling
Mm.
is very varied.
Yeah.
Lot of the variation is there.
Yeah.
That is another problem for me. You know,
Right.
so if I quote this price, because I quote a standard price, even if the company is big or small,
Of
if they
course.
want to run 20,000 or 40,000 operations or
Right.
just 200 operations, the price is same. You know
Right.
and so therefore I put a standard price on the tool.
I see. I see. Yeah, your typical sales leader would tell you to just limit the scope, or say we are not even going to try to sell to this kind of customer. We are just going to try to sell to this kind of customer where
Yeah.
the ROI is high enough, or where you expect the ROI to be
No,
high enough to charge
therefore,
$25,000 and not $500. But makes sense. But yeah, I understand what you're talking about. Yeah.
my idea is to to take this scheduling solution to as many people as possible, as many companies as possible. Not trying to sell at a high price for the good companies. So now my idea is, right now, my idea is even to, yeah, to take it to a machine shop, even with the 10 machines, at a low. I'm thinking on that one. Just reduce the number of operations the tool can handle,
Yeah.
and then give very cheaply to the small shops, so that they can also get benefit out of this one. Right now, we got some clients, who run, they schedule at least 30,000 operations in each scheduling exercise every day.
Right.
We got some company. The same tool is used in some other shops. consisting of like 20, 30 machines,
Right.
20, 30 people. The same tool.
Uh, uh. No, that's fascinating, and I genuinely admire and respect that inventors' desire to for social good and have the invention speak for itself and
People take advantage of it. Small companies or big companies, they should get advantage of it. But the problem is, most of the small companies, they don't have a confidence
yeah.
that scientific tools can really can give good benefit. They are really hopeless. Many small job shops are hopeless that there could be a solution that can help the reduce firefighting. They're hopeless, and they don't have confidence that some software tool can really help them. And they may not have discipline to update job status information on a daily basis to run a scientific tool.
Right.
So this is the reason I'm not able to reach the small companies. Though I wish, to see that they use scientific scheduling software.
Yeah. No, that makes a ton of sense. No, I appreciate the frankness. Prasad, how do you see the balance between AI advancements and human decision making in manufacturing management evolving? I know that in the past, we even used to call operations research as AI, right? That what is AI has evolved over the last 60, 70 years. At some point in time, control systems was called
Yeah,
AI,
yeah.
symbolic systems, just what we write as common programs were called AI, numerical optimization, and then statistics was called AI. And these days it's just new, and obviously neural networks themselves have gone through multiple ebbs and flows. But how do you see the recent wave of AI and human decision making and their balance, and how does it affect your verticals? What are broadly your thoughts on
I think
on
you know better than me. To start with this one, I would say, as I know, the long ago, the AI means constant satisfaction methods. In optimization, it was also used in scheduling, but it was not so spectacular at that time. And I'm talking decades ago. Later, the genetic algorithms are used, simulation, simulate annealing,
yeah,
meta heuristics. They are all brought into AI, artificial intelligence. You know, um, and these are data mining. In olden days, I used to call data mining
yeah,
the machine learning, neural nets. Those words are not used now. People don't talk neural nets and data mining. Now everybody calls AI. So they all morphed into AI. And as you said, the AI right now consists of several parts like the ML, the machine learning, the various statistical methods, and various operations algorithms. You know, I'm seeing some places, some people claim it is AI, but basically they are using some optimization algorithm and to market themselves, they're saying, they developed a AI, solution. So it is going on. I have no objection, but when it comes to the AI applications, in manufacturing industries, I'm wondering what I feel. How right now I don't know much, but I feel it has a tremendous potential. It is a prospect and it's a disruptive technology. It can have a lot of impact in all walks of life. Including shop floors. It can help the workers in their work. It's possible. It can improve operations efficiency. It can improve product quality. But right now, I don't know how it does, but I can imagine I'm very positive. But at this time point, I'm not seeing any evidence, hard evidence that some companies are getting, a cost-effective, significant benefit from AI,
yeah,
on the shop floor.
yeah.
But it has potential.
No,
Uh, and from decision point, making point of view, still I'm not so optimistic that AI can really help in improving scheduling methodology, unless you bring some OR methods
Yeah,
and put in AI. Otherwise, I don't see how ML can improve scheduling methodology.
yeah,
And AI can help mainly now. First of all, it requires a lot of data initially, for to train the nets, it requires a lot of data, but companies may not have right now so much data to train these neural nets. Once it is done, then they can get benefit. It can improve the data quality, but I'm not so optimistic about the role of AI
yeah.
in improving scheduling logic.
Makes sense. I will mostly agree. We should talk more about, maybe afterwards, about some of the applications that we are seeing in industry. You're right, job shops are harder simply because of the wide variety of things that happen there, and
Yeah, yeah,
just the exponential mm, need for data that you'll need to, you apply it to be applicable to job shops. That's for sure. And I also completely agree with the thing that where OR shines, it's OR is the right tool, or
yeah.
constraint based optimization is the right tool. It's the right tool. I don't think there is a feed forward neural network can do that kind of search by any means. But absolutely would love to talk to you and show you some of the R deployments where we're doing, more from a high volume perspective, high
Yeah.
volume shop floors. There are some, we are seeing some really really cool solutions. But yeah, Prasad, what is, this is a question that I ask all my guests. What is, and aligns with the name of the podcast. What is the one thing that manufacturers don't do enough to be factory forward in 2024?
I want them to be open to the potential of emerging technology. Even though there's a lot of hype, everything, but it should not obscure the real potential of emerging technology. They should be open, and they should see how they can, take advantage of it. That's what I feel.
Got it. Fantastic. No, I really appreciate it. Prasad, thank you so much. It was fantastic and absolutely amazing talking to you. I learned a lot out of this, half hour call already. And I'd love to have you again on the podcast, and even other than that, learn from you offline. Thank you so
I
much
don't.
for your time.
I spoke spontaneously without any preparation. It's not a lecture, not a prepared talk. So I don't know what what all I talked.
My,
I hope it makes sense to you.
it does. Yes, sir. Absolutely.
And that's a wrap on this powerhouse episode of Factory Forward. If you loved this episode, share it with your network and keep the conversation going on social media using hashtag Factory Forward. Until next time, keep challenging the status quo and striving for excellence. Thanks for joining us, and we'll catch you in the next episode of Factory Forward.